Okay, we're now into section 7.6, which is going to be the last section that we're going to be covering before the test. If you're able to follow the material in 7.5 with a lot of problems, hopefully you'll be able to take some of the techniques we used to simplify the complex rational expressions to solve the rational equations that we're going to solve here in this lesson. So we're going to go ahead and take a look at question number 18 to begin this lesson to see how we do this. So we have 1 over 2 minus 2 over t equals 3 over 2t. So what we're going to basically try to do is, since we have fractions in this equation, we're going to see what we do to basically get rid of the fractions, much like we did in the numerator and denominator of the complex rational expressions. So to go ahead and do this, we need to take a look at all the denominators in this complex equation. And that's going to be 2t and 2t. So what I'm going to do now is I'll rewrite this again. And if you need to, please stop the video and write this equation as much as to your heart's content to help you see this better. I'm going to multiply everything through now by 2t over 1, because 2t is the least common multiple for this. So I'll distribute this a few times before I stop doing that. If you want to continue distributing it yourself, if you feel that's necessary, that's fine. But I'm not going to do this for all the questions because it takes a lot of time. So I'm going to write this 1/2 minus 2 over t equals 3 over 2t. So when I distribute it through, I'm going to get 2t over 1 times 1/2 minus 2t over 1 times 2 over t equals 2t over 1 times 3 over 2t. And we're going to take a look at how each of these parts reduce that we multiply. So here, what reduces is the 2, and we're left simply with just t minus. What reduces here is the t, and we have 2 times 2, that's 4. What reduces here is the 2 and the t, and we're left with simply 3. So what was at first a complex fraction is a rather very elementary fraction, and you might have picked up even in Math 952. T minus 4 is equal to 3. So we're going to add 4 to both sides, and you get t is equal to 7. So not a real difficult fraction if you are able to clear the denominators out. But to do that, you're going to have to find the least common denominator for those 3 items. Let's go ahead and take a look at question 20, and let's see what work is entailed here. So here we have a minus 4 over, for question 20, a minus 4 divided by a plus 6 equals 1 over 3. Now, there are a couple ways of doing this. One way is to certainly do cross multiplication. If you're familiar with that way, that's okay. I'm going to just kind of stick with this technique because it's consistent with what we did in 7.5, and I want to try to do that. So if I'm looking at the denominators of a plus 6 and 3, I'm going to multiply this entire equation by 3 times a plus 6 over 1. So again, I'm going to write this out with the distribution taking place one more time, where I'm going to multiply this part here by 3 times a plus 6 over 1, and then this part by 3 times a plus 6 over 1. Here the a plus 6 is reduced, here the 3 reduces. So on the top here I have 3 times a minus 4 equals, let's see, a plus 6 times 1 will be a plus 6. Well, I don't need the parentheses now. So if I distribute the 3 now, that's going to give me 3a minus 12 equals a plus 6. And now I have an equation that's going to take a couple steps to simplify at this point. So if I subtract a from both sides, that's going to be 2a minus 12 is going to equal 6. If I add 12 to both sides, that'll give me 2a is equal to 18. And then if I divide by 2, a is equal to 9. and I now have this equation solved. Now, some of you looking at this work will recognize, hey, I could just cross multiply this and get the same result that I have here. And that's correct. You could indeed do that. I'm just at the moment staying consistent with this technique because this technique will work for all of these equations. The technique of cross multiplication is only going to work for a select few. And I'll be glad to show that technique in class if anyone has a question about that. Going forward, let's try next question number 14. So 14 is 1 over 6 plus 1 over 10 equals 1 over t. So in this one we have three different denominators all together. One of the common factors, one of the factors we're going to have to multiply through by is going to be t. In addition to that, we need the least common factor for 6 and 10, and the least common factor for 6 and 10 is 30. So I'm going to multiply this whole thing through by 30t. That's going to be 30t over 1. Don't have to put 30t over 1, but I know for a lot of people, because these are all fractions, writing it that way is probably going to be easier. So what I'm going to do now is I'm not showing all the distribution. Let's go ahead and take a look at what this looks like without it. Well, 30 divided by 6, that's going to be 5. And there's no t to cancel, that's going to be 5t. Here, plus 30 divided by 10, that's going to be 3. The t doesn't cancel, so we put that there. 30 divided by 1, well, that's just simply going to remain 30. However, we have t divided by t, the t is reduced. So we've now gotten rid of the fractions in this. Now we have 5t plus 3t equals 30. So simplifying this, we combine our like terms to come up with 8t equals 30. And then dividing both sides by 8, we get t is equal to 30 over 8. We can't leave the answer in this form. We've been simplifying rational expressions. Certainly, we can simplify this. Now, you could, if you want, try to do this in prime factorization. So let's go ahead and do that. 30 is 2 times 3 times 5. 8 is 2 times 2 times 2. Only the 2's we can get rid of. So final answer to this question is going to be 15 over 4. So the value of t in this one is 15 over 4. And yes, you can sometimes get fractions for answers to these equations, especially given that there are fractions in the problems themselves. Okay, we won't try to cram another problem on that page. Let's go ahead now to question number 24. Similar technique in this question here, about the same level of difficulty, but good for reinforcement. We have 12 over 15 minus 1 over 3x equals 4 over 5. So we look at 15, 3, and 5. Hopefully most of you recognize 15 is the least common multiple of these three numbers. And we have an x here also. So I'm going to multiply everything through here by 15x over 1. Let's see what we get when we multiply that through. Well, 15 divided by 15, that's 1. So the 15 will go away here. So it'll be x times 12, or 12x. If I take 15 divided by 3, that will be 5. So that's going to be 5x times the negative 1, or negative 5. But x divided by x is nothing, so 15x divided by 3x will be just simply 5. And we have it multiplied by 1, so that's going to simply be 5. Here we have 15 divided by 5. Well, 15 divided by 5 is going to be 3. That's going to give me 3x. 3x times 4 is going to equal 12. So now we simplify this to 12x minus 5 is equal to 12. We add 5 to both sides. So 12x is equal to 17. Let's see here. I want to check my work a second. 12x minus 5. 3x, 12. one thing I forgot, I need to make this 12x. So let's see what happens when we do that. So watch this carefully. Easy to make the mistake. 12x minus 5 equals 12. Well, if I were to take away, so cross this out, let me write this again. If I were to take away 12x from both sides, I get negative 5 is equal to 0. So this happens with equations sometimes where these type of equations have no solution. My apologies for my missed stuff. You might have caught me on that, but I did catch myself. So this equation, because we don't get x set to anything, this equation has no solution. So 24 is an equation that has no solution, and you may see this come up, in fact, a little later. Let's go ahead and take a look at question 30 at another similar example of this. So here we have 4 over 8 minus a equals 4 minus a over a minus 8. So one technique that you can use for this, and this could help quite nicely, is if we can get these denominators to be common, we can get rid of the denominators very easily and go straight to the numerators. So if you see this, you're looking at 8 minus a and then a minus 8. I can factor out a negative 1 out of this. So I'm going to go ahead and do that on my pink marker. Now when I factor out the negative 1, I'm going to rewrite this, but with a negative on top. So I'm going to write this as a negative 4 over a minus 8 equals 4 minus a over a minus 8. And now that we have the same denominator, if I multiply through a minus 8 over 1, I'm going to get negative 4 equals 4 minus a when I do this here. Because when I multiply this through, I get rid of a minus 8, I get rid of a minus 8. So when I do this now, I'm getting a different answer than the book's giving me, so I'm going to hold off on giving this example at this time. I'll probably come back to it later. Let's go to the next question. We're going to go to question 36. Then this is going to be x squared minus 1 over x plus 2 equals 3 over x plus 2. So you'll notice that in these, we have the same denominator. So one way to get rid of this really quick is that when these two things have the same denominator, I can just multiply through by x plus 2 because that's over 1, because that's going to be the same denominator. So when I multiply this through, denominators disappear, giving me x squared minus 1. When I multiply through here, these disappear, giving me simply 3. Once I obtain this for a solution now, I'm going to go ahead and I'm going to add 1 to both sides. So I'm going to get x squared is equal to 4. And when I get x squared equal to 4 for this now, I can take the square root of both sides, and I'm going to get x is equal to plus or minus 2. However, when you get a solution like this, especially one that involves quadratics, we need to check that both solutions work. So this is another little trick we're going to run into. So let's say, for example, I put the solution of 2 into this equation now. So let's go ahead and we're going to let x equals 2 for a check. We'll get, for this now, 2 squared minus 1 over 2 plus 2 equals 3 over 2 plus 2. Well, 2 squared minus 1, that's 3 over 4, equals 3 over 4. That's no problem. Let's try this for when x is equal to negative 2. And let's see what happens. Well, we get negative 2. We get negative 2 squared minus 1 over 2, or excuse me, negative 2 plus 2 equals 3 over negative 2 plus 2. Well, we have negative 2 plus 2. That's going to be 4. So we got 3 here, but here we've got 3 over 0. Here we get 3 over 0. Now, you may have said that these are equal, but remember, we cannot have a 0 in the denominator of the final answer. So because we can't have 0 in the denominator of this answer, then this has no solution. So we can't accept this because this is undefined. So therefore we say this has no solution. So I think if we go back to 30, I think we can run into the dilemma of what's going to happen with this one. So let's go back to 30, and we'll rewrite this as negative 4 equals 4 minus a. When we solve this, we're going to go ahead and subtract 4 from both sides. We're going to have negative 8 is equal to negative a. When we divide by negative 1, we're going to have a is equal to negative 8. Here's the problem. If we put negative 8 into a denominator here, or excuse me, not negative 8, but positive 8. If we take the value of positive 8, because negative 8 divided by negative 1 is 8. If we put 8 into here, 8 minus 8 will give us 0. So even though we obtain a solution, we cannot use it because it makes the denominator 0. It does not work. Therefore, there is no solution to this. Okay? So one of the things that we're going to have to be mindful of is to make sure that the solution, that if we get a solution, we may have to put it in to see if it gives us a 0 in the denominator of a fraction. So we'll be more vigilant to look for more of those questions in the upcoming future. Let's take a look now at question number 40. In question number 40, we have 50 over t minus 2 minus 16 over t equals 30 over t. So in this question now, we have t minus 2 and we have t. So I'm going to go ahead and multiply the whole thing by t times t minus 2 over 1. And let's see what reduces as we distribute this. Here, the t minus 2 is going to reduce, but the t is not. So this is going to be 50 times t minus. Here, the t's are going to reduce. The 16 won't, and the t minus 2 won't, so it's going to be 16 times t minus 2. For this one, the t is reduced, but the t minus 2 does not, so this is going to be equal to 30 times t minus 2. Some of you who may be stronger may have decided, you know what, I'm going to go ahead and add 16 over t to both sides, so I would have 46 over t, and yeah, you could have done that. So if you took it with that technique, that is a perfectly legitimate technique to approach it with. So let's go ahead and distribute what we can here. So I'm going to get my black marker out again. Negative 16 through this, and then 30 through this. By doing that, we're going to get 50t. Let's see. Negative 16 times t is negative 16t. Negative 16 times negative 2 is plus 32. 30 times t is 30t. 30 times negative 2 is negative 60. So let's see if we can clean up on both sides. 50 minus 16, that's going to be 44t plus 32 equals 30t minus 60. Well, at this point, let's go ahead and start moving, getting the t's to one side. Subtract 30t. That'll be 14t plus 32 is equal to negative 60. If I subtract 32 from both sides, that's going to be 14t is going to equal negative 92. And if I take my final answer here, I'm going to get t is going to be equal to approximately, let's see, 92 divided by 14. 46. I'm going to get approximately negative 46 over 7. I can write negative 92. I can write this as 2 times 46. I can write 14 as 2 times 7. That is as simple as I can get that one. Now, just to kind of quickly look over here, because there's a lot of room for error in this. If you happen to catch an error that I might have made, oh, yes, I see my error right away. This is 50 minus 16 should not be 44, it should be 34. So 34. Just I like to inspect my work from time to time. So 34 minus 30 is going to be 6, or 34 minus 30 is going to be 4t. Here, let me take a look to make sure I'm not committing any further atrocities. So 4t plus 32 is negative 60. So I should have 4t equals negative 92. So if I have 4t is equal to negative 92, and I divide by 4, t is going to equal negative 23. And that should be my final answer to that question. I'm a little off. I apologize for that. Hopefully as you're going through, you are catching in some of my mistakes. So if you need to watch the video again with my mistakes in mind, again, I apologize. When I have more time to edit these and clean them up, I will certainly do so. Okay, let's take a look at 2 more questions to close off this section as well as Chapter 7. We have question 44. This is going to be x over x plus 1 plus 5 over x equals 1 over x squared plus x. So one of the things we may have to do sometimes is we may have to do a little factoring of some of the denominators here to see what the factors are, so we can more readily identify what our common factors are going to be, or what we're going to have to multiply through. So if I were to factor the denominator of the fraction on the right, well, I can write this as 1 over x times x plus 1, which happen to be the 2 factors that are over here. So in taking that little step, we can save ourselves a lot of extra work by just simply identifying the 2 common factors of x times x plus 1 as what we need to multiply through by. So when I multiply this through, x plus 1 reduces, but the x times x does not, so that gives us x to the second. Here the x reduces, the 5 and the x plus 1 does not, so that's going to be plus 5 times x plus 1. Here the x and the x plus 1 reduces, all this is going to equal 1. Well, it looks like that this is probably going to give us a quadratic equation, and let's see what type of solution or solutions this is going to produce. So this will be x squared, distributing this through, plus 5x plus 5 is going to equal 1. When I subtract 1 from both sides, I get x squared plus 5x plus 4 is equal to 0. Now, solving quadratic equations like this is work that you learned back in Math 90. So let's take a look at how this gets done. So we want to solve these quadratic equations, so we first have to factor them. So the factors for x squared plus 5x plus 4 are going to be x plus 4 times x plus 1. Well, this still gives us 0. So if we want both solutions to this, we need to set each of these factors equal to 0. So hopefully this is something you recall. If you have more questions about it in class, I'll be certainly glad to answer those and work on this a little more. But this is a skill that should have been covered back in Math 90. By setting each of these equal to 0, I solve for x. And here I'm going to get x equal to negative 4. And here I get x equal to negative 1. Again, we want to be mindful that perhaps one or both of these solutions may cause the denominator to be 0. So, for example, let's just take the value of negative 4. Negative 4 plus 1, well, that's going to be negative 3. That's okay. We can have a negative there. Negative 4, that's fine. Negative 4 squared is going to be 16. 16 minus 4 will be 12. That's okay. But let's take a look at negative 1. if we take -1 and put it in here, -1 plus 1, that's going to be 0. That is not going to work. So we cannot accept the solution of x being equal to -1 because it's going to make this part of this fraction undefined. So therefore, we can accept x equal to -4 as the only solution for question number 44. We're going to take a look at one last question, and that's going to be number 38. So we're going to have 4 over a minus 7 equals -2a over a plus 3. If we're looking to multiply anything through to try to clear the denominators, because these are two different entirely denominators, the best we can do is simply multiply by the product of these, which is a minus 7 times a plus 3 over 1. When we multiply this through, the a minus 7 reduces, but the a plus 3 does not. So this would be 4 times a plus 3. When we multiply this through here, the a plus 3 reduces, but the a minus 7 does not. So here we're going to have -2a times a minus 7. And this is where it appears that we're going to get something that's in a quadratic form. So let's distribute 4 through here, -2a through here. This is going to be 4a plus 12. This is going to be -2a squared plus 14a. So what I'm going to do, because I'm going to try to keep my a squared term positive, I'm going to try to move everything over here. So let me go ahead and add 2a, and let me go ahead and subtract 14, or 2a squared, and subtract 14a from both sides. So I'm going to add 2a squared and subtract 14a from both sides. Let's see what this gives us. This side goes to 0. That's what we want because we have a quadratic equation. Here we have 2a squared minus 10a plus 12. So now we have a quadratic equation that we need to solve. So some factoring is going to be needed here. So here's where this gets a little tricky, because the first type of factoring, again, you always want to try is the greatest common factor. So first, I'm going to go ahead, I'm going to factor 2 out of this to get a squared minus 5a plus 6. And that's equal to 0. Well, we don't want this a around. So at this point, if we divide both sides by 2, 0 divided by 2 is still 0. Now we'll be left with a to the second minus 5a plus 6. From this point now, we have a quadratic equation that can be factored. And this is going to be a minus 3 times a minus 2, and that's going to be 0. We're going to set each of these factors now, like we did in the previous problem, equal to 0. And what minus 3 equals 0? Well, 3 minus 3. So I'm going to add 3 to both sides. Get a is equal to 3. And I'll add 2 to both sides. Get a is equal to 2. So again, we're going to go ahead and just check these answers, put them in the denominator, and make sure that nothing reduces. So we have a equals 3. 3 minus 7 is -4. That's okay. Then we have 3 plus 3. That's 6, so that's fine. Here, 2 minus 7 is -5. That's perfectly okay. 2 plus 3 is 5. So as long as we don't get 0 in the denominator, we can accept both of these answers as solutions to these equations. So this is the last example, and we are now closing off Chapter 7. Be sure to watch these videos by Monday, February 3rd, so that you get the necessary help in class that you need to be successful in this unit. Thank you very much. Have a good night.